Hi everyone, my name is Shovinashni Anapanupan Ramanan, no matrix CN250014. We are from section 1, group 1. Today we are going to present about measuring the world around us. As you all know, when everyone hears a topic of measuring the world around us, always sounds like, how are we going to do that? How are we going to measure the world? And is that possible for us? Okay, let's see how we're going to solve it by using physics.
Okay, this is our group member. This is Nurul Nadia Atira, and then Shovi Nashni, Nurul Atira, Muhammad Aiman Hakim, Muhammad Adam, Muhammad Amar Mustaqim, Muhammad Afizi, and me, Syam Syabu Dewi Muhammad Syahrin. We are have eight member from the group 1. So next to the introduction from my members.
Okay, let's look at the introduction. Measurement is the basis for all scientific inquiry and engineering practices. Besides, accuracy refers to how close measurement is to the true value. Accuracy is limited by the precision of the instrument being used. Moreover, all the measurements have some degree of uncertainty that must be understood to interpret results. Besides, calculated quantities and derived from measured values causing uncertainties to propagate. Lastly, a calculation result cannot be more precise than the least precise measurement used in the process.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Nadia Atira binti Muhammad. My metric number is CN250021. Objective of the project is, for the first, to compare the accuracy of different measuring instrument, and second, to measure the diameter and volume of the small object using different tools. Third, to analyze measurement errors and calculate percentage uncertainty. And lastly, to present how significant figure affect final result.
So next I will explain the apparatus and material we use for this experiment. So first we use a pen caliper to measure external diameter of 100 plus scan and thickness of the coin. So it gives more accurate reading to compare a normal ruler. So next is a micrometer. So we use a micrometer to measure a very simple thickness, such as we used to measure a thickness of 50 cent coin with a very precision. So next is a ruler. So we use a ruler to measure the length and height of the object as a basic measurement and for comparison. So for material, we use a 50 cent coin. The 50 cent coin we use to as the object to measure its diameter and thickness using a measuring instrument. So the last bit is 100 plus scan. So we use a 100 plus scan to measure its diameter. We are using a pen caliper. So these are all material and apparatus we use for this experiment.
Next is procedure. So I will presenting the procedure of using the vernier caliper. So a vernier caliper can measure the inside, outside, and depth of objects with an average accuracy of 0.02 millimeter or 0.001 inches. It's used in laboratory and workshop measurements is because it gives precise and reliable readings if properly used. So to use the vernier caliper, firstly, you need to take care the jaws and the object are clean and dust, oil and debris free. For this factor may have an impact on the accuracy. Secondly, is to measure for outer dimension. It should be very carefully put in the between and external jaws, or if it is to be measured for inner dimension, it should be gently placed inside the internal jaws. After obtaining the correct position, secure the measurement by tightening the locking screw before taking the caliper off the object. So the next is procedure of using micrometer screw gauge. A micrometer is a measurement instrument used to measure the external size of object with extreme precision, like the thickness of a sheet, small parts, and the diameter of a wire. Usually accuracy in it is 0.01 millimeter or 0.0001 inches. So the first step is it is necessary to clean the anvil and spindle surface to get rid of any dust or residual. Then to close the anvil and spindle is by using the ratchet gently until it slips 1 or 2 click and check the zero error on the sleeve and timber scales. Secondly is position the the object directly in the middle of the anvil as spindle. Being very careful to align it perfectly and keep it straight. Slowly turn the ratchet and stop clockwise until it clicks or 2 or 3 times with a distant sound. And lastly, before taking the micrometer off the object, secure the reading using either the lock nut or lock ring. Then take the value of the main scale and thimble scale and add both reading up to get the final measurement.
So for data and observation of first item, which is 100 plus scan, so we calculate the diameter of 100 plus scan using a ruler. For the first trial, we got 58.00 millimeter. However, for trial 2 and trial 3, we got the same amount, which is 59.00 millimeter. And average for this measurement is 58.67 millimeter. And now for the second measurement instrument, which is we're using a vernier caliper. First trial, we got 57.10 millimeter. And for trial 2, we got 57.12 millimeter. And lastly, for trial 3, we got 57.11 millimeter. Average for this measurement is 57.11 millimeter. And now for the second item, which is all 50 cent coin. For the first, we measure the thickness of an all 50 cent coin using a ruler. For the first trial until the third trial, we got the same amount, which is 2 millimeter. So average for this measurement is 2.00 millimeter. And now for the second measurement instrument, which is a vernier caliper. For the first trial, we got 1.61 millimeter. Second trial, we got 1.65 millimeter. And for the trial 3, we got 1.664 millimeter. Average for this measurement is 1.633 millimeter. And now for the last item, we're using a micrometer screw gauge. For the first trial, we got 1.593 millimeter. For trial 2, we got 1.592 millimeter. For the trial 3, we got 1.594 millimeter. Average for this measurement is 1.593 millimeter.
Assalamualaikum, my name is Muhammad Adam Ghazali. My matrix number is AN250168. From this graph, it shows that the diameter of the 100 plus can be measured using two different instruments, which is a ruler and a vernier caliper over 3 trials. From the graph, we can observe that the ruler measurement varies slightly between trials, ranging around 58 to 59 millimeter. These show that the ruler is less precise. On the other hand, the vernier caliper measurements are almost constant across all trials at around 57.1 millimeter. This indicates that the vernier caliper gives more consistent and precise readings. Therefore, the vernier caliper is more suitable for measuring the diameter of the can compared to the ruler. Next, let's move on to the other graph. This graph shows the thickness of an old 50-cent coin measured using 3 instruments, which is a ruler, vernier caliper, and micrometer screw gauge over 3 trials. The ruler shows a constant reading of about 2.0 millimeter, which is a quiet height. This suggests that the ruler is not accurate for very small measurement. The vernier caliper gives readings between 1.61 mm and 1.65 mm, showing slightly variation. The micrometer screw gauge gives the most consistent readings around 1.59 mm for all trials. This proves that the micrometer screw gauge is the most precise instrument for measuring very small thickness like a coin. In conclusion, instruments with smaller list count, such as the vernier caliper and micrometer screw gauge, provide a more accurate and consistent result compared to a ruler.
My name is Muhammad Aiman Hakim, matrix number CN240308. And next, we'll proceed for the calculation. We assume the 100 plus can as a perfect cylinder where the volume is calculated using the formula V equals to pi r squared times height. By using a ruler, the average diameter obtained was 58.67 millimeters, giving a radius of 29.335 millimeters with an uncertainty of plus minus 0.25 millimeters. Using a vernier caliper, the average diameter was 57.11 millimeters, resulting in a radius of 28.555 millimeters with a much smaller uncertainty of plus minus 0.025 millimeters. When comparing the radius squared term, which is critical in volume calculation, the ruler gave a value of 860.6 square millimeters, while the vernier caliper gave 815.4 square millimeters. This shows a difference of about 5.5%, even though the diameter difference was only 1.56 millimeters. For the thickness of the old 50-cent coin, the ruler showed the highest percentage uncertainty at 25%, while the micrometer screw gauge produced the lowest uncertainty at 0.031%. confirming that instruments with smaller least count provide more accurate results. For our discussion, we focus on how measurement accuracy affect the calculation of volume and thickness. For the 100 plus can, the diameter measured using a ruler was 58.67 mm, while the vernier caliper gave more accurate value of 57.11 mm. Although the difference seems small, it caused about 5.5% difference in the radius squared value, which significantly affect the calculated volume because the volume is proportional for the square of the radius. For the 50-cent coin, the ruler showed the highest uncertainty at 25%, making it unsuitable for small measurement. The vernier caliper improved the accuracy, while the micrometer screw gauge gave the most precise and consistent result. Overall, this experiment showed that choosing the correct measuring instrument is essential to obtain accurate and reliable result in engineering application. That's all from me. Thank you.
Assalamualaikum. My name is Nurul Atira binti Muhammad Hanafi. My metric number is CN220331. So today I would like to present for conclusion part. So first, measurement accuracy depends on choosing the right instrument for the task and experiment. Using high resolution tools to help reduce uncertainty and give more reliable result. So even small measurement errors can lead to large calculation error, especially for values like volume. So accurate measurement are important to ensure good quality control, safety and cost efficiency in industry such as engineering and industry. They also help to improve scientific understanding and proper engineering practice. So for in the future, artificial intelligence can support measurement by enabling automatic reading, detecting errors, improving calibration, and increasing consistency in smart laboratories and manufacturing systems. So that's all from me.
Moving forward, the next slide will detail the practical procedure for using this measurement instrument and the specific technique required to obtain accurate readings. Goodbye.
First, let's look at the vernier caliper, a versatile tool used to measure the external diameter of this can. Slide the outer gel until they touch the surface of the object perfectly to get a firm grip. Finally, combine the readings from the main scale and vernier scale for the result to be more precise than a standard ruler. Next, we use a micrometer screw gauge to measure the thickness of a coin. Place the coin between the anvil and spindle. Then, rotate the ratchet until it fits gently. Finally, read the main scale and thimble scale to obtain an accurate measurement.